Hey guys, welcome to lesson 2 on multiplying and dividing exponents. Before we dive into some new content, let's go ahead and let's take a look at lesson 1.9. Oh my god. Hey guys, welcome to lesson 2 on multiplying and dividing exponents. Before we dive into some new content, let's go ahead and let's review lesson 1.1 on zero and negative exponent rules. So in the first example that I have here, I don't even have my pointer, Jesus. Oh, perfect. Okay, let me do this. Hey guys, welcome to lesson 2 on multiplying and dividing exponents. Before we dive into some new content, let's go ahead and let's review lesson 1.1 on zero and negative exponent rules. So in the first example, I have a negative exponent. And when we have a negative exponent, we want to go ahead and we want to take the reciprocal of our base so that we can rewrite it as a positive exponent. When we have a reciprocal, what we're doing is we're essentially flipping the fraction. So I'm going to go ahead and showing you this term as a fraction. All I did is I put a 1 under it. And I'm doing this because I want to show you guys how it flips. Currently, the 1 is the denominator. The 1 is in the bottom. When I flip it, it's going to be at the top. And now my exponent is positive. So this is my final answer. I've rewritten it with a positive exponent. Okay. Now in example 2, I'm going to be combining both the zero exponent rule and the negative exponent rule. Whenever you raise any value that's non-zero to the zero power, you're going to get 1. So I'm going to go ahead, I'm going to show you guys the first step here. I have 1 for a to the 0 power, and for b to the negative third power, I've written it as a fraction. I put a 1 under it. And I'm doing this because I'm now going to find the reciprocal. I'm going to flip it, which means that I'm going to have 1 on the top, and now my exponent has turned positive. And this is my final answer because all I was doing was multiplying by 1, and that doesn't change the value. All right, so now let's dive into some multiplying rules, multiplying exponents. And we call this rule the product rule because the word product is an answer to a multiplication problem. I want you guys to make some observations as I fill in this table. I'm going to be writing this expression as repeated multiplication. Okay, so in my first example, I have 3 to the fifth power, which is 3 times 3 times 3 times 3 times 3. And I also have 3 to the second power. And when I write that product as a power using the product rule, I get 3 to the seventh power. Let's go ahead and let's take a look at the next example. I've listed this out as 5 to the fourth power and then 5 to the second. And when I write it as a product as a power, I get 5 to the sixth power. We're still making some observations here. 7 to the fifth power twice, which gives me 7 to the 10th power. So I wanted you guys to see that essentially what we're doing with our exponents is we're adding them. Our product rule is a shortcut, guys. Why would we want to waste so much time writing this as repeated multiplication when we can just add our exponents by using the product rule? In order to be able to use the product rule, your bases need to be the same. So if your base is the same, you can go ahead and keep the base and add the exponents. That's what the product rule is. So let's go ahead and let's apply the product rule so we can write these examples as a single power. So I can clearly see that my base is the same. Here in the first example is 4. So I can take my exponents and I can add them. I can do 3 plus 1. And now when I write this as a single power, I have 4 to the fourth power. Today we're not evaluating. We're stopping right here. Okay. Next example, I have 5 as my base. It's the same. So I can go ahead and take 3 and 9 and I can add them to get 12. Okay, so I know example 3 looks a little bit different, but we're still going to be applying the product rule. I have coefficients now. A coefficient is a number that's in front of a variable. It leads it. So I have 6 and I have 8. And you can clearly see that I have some parentheses here. We are going to be multiplying our coefficients. I'm going to do 6 times 8. That's going to give me 48. Now with my exponents, I'm still going to have to add them, okay? So we're doing two things. We're multiplying our coefficients, which gave me 48, but I'm adding the exponents at the same time, which gave me 7. So that was my final answer there. Okay, so when we multiply powers, when we're multiplying exponents, we add the exponents. Okay, so let's go ahead and let's look at division. When we're dividing powers, what happens? And this is called the quotient rule because the word quotient is an answer to a division problem. So again, we're going to make some observations here. Okay, so here I have 8 to the 5th power divided by 8 to the 3rd. Notice how it's being represented as a fraction. Now, I can essentially cross some of these 8s out. And I'm doing that because 8 divided by 8 is going to give me 1. So I know sometimes you guys have heard the term of cancel out. I want you guys to think about this. Don't necessarily use the word cancel out. The reason we're able to cross them out is because 8 divided by 8 is 1. And the value 1 is not going to change the value of this answer. So I'm left with 8 to the 2nd power. I'm going to do that as well for the next example. I have 5 to the 6th power on top and 5 to the 5th power on the bottom. And this is repeated multiplication. So I can go ahead and I can take out some of these 5s. I can cross them out because again, 5 divided by 5 is 1. And that's not going to change the value of my final answer, which is 5 to the 1st power. I'm left with 1 5. Again, I have 4 to the 9th power on the top, written in expanded form, and 4 to the 3rd. I can go ahead and take out 3 of those 4s, which leaves me with 4 to the 6th power. So what were we doing with our exponents? We were subtracting them, guys. When we are dividing powers, dividing exponents, we use the quotient rule as a shortcut. We can go ahead and take our exponents and subtract them as long as the base is the same. So we keep the base the same and we subtract the exponents. Okay, so let's go ahead and let's do some flex time. Let's put what we just learned into action. Okay, so the biggest takeaway for today is when we're multiplying powers, we keep the base and we add the exponents. Okay, here it is in algebraic form. And when we're dividing powers, we keep the base and we subtract the exponents. So let's go ahead and let's do an example 1. In example 1, I need to ask myself, am I going to be applying the product rule or the quotient rule? Well, I see a dot here, and that represents multiplication. So because I'm multiplying the same base, I can go ahead and add my exponents. So my final answer would be 13 to the 7th power. Same thing here. For example, B, there's a dot there, which represents multiplication. So I'm going to be adding my exponents. Okay. All right. In example C, I do see a division sign, so I am going to be applying the quotient rule, but I'm missing an exponent. Whenever you're missing an exponent, you can go ahead and put a 1 there. Okay, so I'm doing 13 minus 1. That gives me 2. So I have 15 to the 2nd power. And then finally, here I have a fraction, guys. A fraction represents division. And I also have coefficients. Please remember, when you have coefficients, whatever operation you're doing, you're going to follow through with that. Here I'm doing division. So I'm going to divide 25 by 5, which is going to give me 5, but I'm going to be subtracting my exponents, okay? So I'm doing 2 things. I'm dividing, and then I'm subtracting my exponents. Okay, guys, good luck on your formative assessment tool.